Good morning. Welcome to the second part of this test review. So in this part, I'm going to be going through and looking at mostly the inverse trig functions and what we learned to do with those. All right, so one of the first things that you want to know is you do need to have these memorized. And I can show you a couple of ways to help you remember this. So the inverse sine, the inverse cosine, inverse tangent. Well, you're always looking for two quadrants with one quadrant the trig function being positive and one quadrant the trig function being negative, and you'll always be in quadrant one. So it's the choice is either to add on quadrant 2 or quadrant 3. This is one way you can remember this. So the thing is, like a sine, if you're looking at a sine is positive here, negative there, and negative there. So the obvious way to do the sine is that way. Okay, you don't want to skip a quadrant and go like that. So the range on this is going to be from negative pi over 2, and we're going to have a consistent range here. You're not going to jump to 3 pi over 2. So what you're doing is moving all the way from negative pi over 2 to pi over 2 like that. So you want to have one interval, if you can, with the trig function being positive in one and negative in another one. That's the way I remember this. Okay, so now if you look at a cosine, so a cosine is positive here, positive there, negative there, negative there. Because a cosine is the x value on a unit circle, and x is positive to the right, x is negative to the left. So the logical way to do this, again, is not have these opposite quadrants, but to put it together this way. Okay, so the range of a cosine is going to be 0 to pi. Okay, so that's how you put that together. It's not that hard to remember. And you only have one answer to an inverse trig function. So you're trying to get an interval that's right around 180 degrees, and part of it will be positive and part will be negative. So a tangent works same way as a sine does. So a tangent is positive here and there and negative there and there. Okay, so the logical way to do this, now this one is kind of debatable. You could put it together this way, but the standard is to put it together this way. Okay, and part of the reason for that, I think, is you would have an asymptote. You have a vertical asymptote at pi over 2. So to keep from having to write out two separate intervals, we chose to do it this way. Now the only thing with this is you got parentheses around these, because remember a tangent is equal to y over x, and what you're going to find is at pi over 2, you're going to end up having 1 over 0, so you're undefined. Since you're undefined, you have to have a parenthesis there. And same thing here, if you're at negative pi over 2, negative 1 over 0 is undefined, so you have that. So that's, not just blind memorization of that, but you can actually reason that out a little bit, okay? All right, now what's important when you're dealing with these functions is to know these ranges. So all the rest of these problems, one of the things that's important when you're doing a trig function, you're only going to have one answer when you do an inverse trig function. One of the mistakes that I see students make sometimes is thinking that there's two answers to these problems. There's only one answer. This is a function. So for this particular value, you're only going to get one angle. So whenever you're doing an inverse trig function, this one I think you're supposed to get the exact value and using the unit circle. The range of an inverse sine is negative pi over 2 to pi over 2. So that's important. And this really means this. It means the sine of what angle is square root of 2 over 2. Okay, now this is a positive value right there. So that means you have to be in quadrant 1. Okay, so on an inverse sine, you're either in quadrant 1 or you're in quadrant 4, because your range is from negative pi over 2 to pi over 2. Now you look up the y value. The sine is the y value, so determine where that happens, and that's going to happen at pi over 4. Okay, so what you're doing is you're working in reverse on these problems. So the answer is pi over 4. Okay, the meaning of this problem is the sine of pi over 4 is equal to square root of 2 over 2. Therefore, the inverse sine of square root of 2 over 2 gives you that angle pi over 4. So that's how you look through that then. Okay? All right. Next problem. Now we're just dealing with an inverse cosine. So its range is 0 to pi. So that means in an inverse cosine, you're looking either at quadrant 1 or you're looking at quadrant 2. Only one answer. This is a positive value. So you're looking at where x is square root of 3 over 2. Okay? So that is going to happen right here at the angle pi over 6. Okay, so that's how you get your answer to that problem. Okay, so again, the meaning of this problem is it's cosine theta equals square root of 3 over 2. We found that the angle cosine of pi over 6 is equal to square root of 3 over 2. So you're working totally in reverse when you do these problems. Okay, all right. Next thing we'll look at is here's an inverse tangent. Okay, so on an inverse tangent, the range is negative pi over 2 to pi over 2. Okay, that means that your answer is either here or there. The tangent is positive there, it's negative there. So, since this is negative, this is going to tell us that we're in quadrant 4. And your answer has to be in this range here. So you couldn't use one of these angles like 3 pi over 2, 5 pi over 3, 7 pi over 4. You can't. So the meaning of this problem is tangent of theta equals negative 1. Now the tangent of theta by definition is y over x. So what you're doing is you're looking at this quadrant because you have a negative number, negative 1, and you're trying to figure out where y over x is negative 1. Well, that's going to happen here because negative root 2 over 2 divided by root 2 over 2 is equal to 1. Okay? But you cannot give the answer 7 pi over 4 because that's out of range, so you have to go to the negative angle, which would be negative pi over 4. Okay? So that's how you reason that problem out. Okay? You have to pay attention to the range, but you also have to understand you absolutely must know the definition of the 6 trig functions. Okay, problem number 13, we're looking at an inverse cosecant. Now, one of the things I told you all is that I'll give you these things right here. You don't have to worry about memorizing these. These you don't use as much in higher math, but I do think the inverse sine, inverse cosine, inverse tangent, you use enough that you want to know those. So one thing on this is the range on this is going to go from negative pi over 2 to 0 to pi over 2. And an inverse cosecant, of course, that's a reciprocal of a sine. So it's either going to be in one of these two quadrants, or you have a positive in quadrant 1 and a negative in quadrant 2 or quadrant 4. Okay, so the reason that there's parentheses on the 0 is because you're undefined on this. Remember, a cosecant is r over y, so in a unit circle r is 1, so at 0 you would be undefined, and so that's why you have to eliminate that 0 from the range. So the meaning of this problem is cosecant theta equals negative 2, and I'm going to put that over 1. Well, the sine is the reciprocal of the cosine, so you could change this to this. Now your answer has to be in this interval, but now all we got to do is look at where the y value, since that's what a sine is, where is the y value negative 1/2? And it's got to be on this range, so that is happening right here. But again, common mistake, you cannot use 11 pi over 6 because that's outside of the range, so you must go with a negative angle, and that's negative 30, So that's going to be negative pi over 6. Okay, so that's how you make that determination on that problem. Okay. Okay, now moving ahead, now we're looking at the arc trig function. It's the same thing as inverse. I just kind of interchanging these. So on an exam, I would ask it either as an arc tangent or an inverse sine, but they mean the same thing. So the range of an inverse tangent, and I think on these problems they want the answer in degrees. So I'll kind of pay attention to that as we're doing this. So the range, I guess in degrees, the range would be going from negative 90 degrees to 90 degrees, or negative pi over 2 to pi over 2. We want the answer in degrees, so that doesn't matter which way you write that range. So what this is saying is the tangent of theta equals square root of 3, like that. And what you have to do is you have to remember that the tangent of theta is y over x. And since this is a positive number, this is going to work the same way that the inverse sine does. So you're either in here or you're in there. You're either in 1 or you're in 4. Okay, since this is a positive, this means you're in quadrant 1. Okay, now you got to look at, okay, where would y over x work out to be square root of 3? That's going to happen here, because if you did square root of 3 over 2 divided by a half, that would work out to give you square root of 3. So that answer is going to be in degrees, 60 degrees. Okay, so that's how you figure that out. But not a lot of work to show on these problems. It's just knowledge of the unit circle. Okay, next problem. The range of an inverse sine, arc sine meaning the same thing, is in degrees. This would be negative 90 degrees to 90 degrees like that. Okay, one thing that you have a negative this time. Okay. So what happens in this one is you're either in quadrant 1 or you're in quadrant 4, because this is an inverse sine, okay? And this is a negative number, so that's going to force you to be in quadrant 4. So the meaning of this problem is sine theta equals negative 1/2. What you're looking at is the y value. So you look on the unit circle at where y is equal to negative 1/2. That's going to be there. Remember, you're not looking at these quadrants there. So now the thing is, 11 pi over 6 is not the answer. And I guess in degrees that would be 330. That's not the answer because it's out of range. So you have to go this way, and then that would be written as negative 30 degrees. Okay, so that's how you put that together. Okay, continuing on here to the next page. Again, the range of the inverse sine in degrees is going to be negative 90 degrees to 90 degrees. So that means we're either in quadrant 1 or in quadrant 4. This is a negative number. That forces us to be in quadrant 4. So the meaning of the problem is sine theta equals negative 1. You look at where y is negative 1, which is here. And again, same thing, 270 is not an answer because it's not in that range. So you have to use the negative angle. So the answer to that problem is negative 90 degrees. Okay, all right, next problem, cotangent. Okay, so cotangent is one of these things now that I said that I would give you the range of. So like on the formula sheet I gave you all, these are the things that I was going to give you. So I will give you this range right here. That's 0 to pi. Okay, so let me go back to where we were here. Okay, so on this one, the range is 0 to 180 degrees if we're dealing with degrees. And the meaning of this problem is cotangent theta equals square root of 3. And again, what we're looking for is we're looking for where the ratio x over y is equal to square root of 3. Okay, so this is a positive number. Anytime you're doing a positive number, on any inverse trig function, you're going to be in quadrant 1. So you got to look and see where would x over y work out to be this. Well, this would be the key, would be right there. Because if you do square root of 3 over 2, the x value divided by the y value, you're going to get square root of 3. Okay, so that means the answer to that problem is going to be 30 degrees. Okay, next one. Range of inverse cosine is going to be from, in degrees, 0 to 180 degrees. And that will be a bracket on both of those. So the meaning of this problem is cosine theta equals 0. What you're doing is, again, you're looking at either quadrant 1 or quadrant 2. And again, you're looking at the x value on a cosine. So you're just looking, where is x 0? Okay, so what happens is x is equal to 0 right here. Okay, so that means the answer to the problem is going to be in degrees, is going to be 90 degrees. So we're doing everything in reverse. The cosine of 90 is equal to 0. Okay, so that's how you would get the answer. Okay, and one last one here. Again, on the secant, if you look at this formula sheet here, the inverse secant is really just like the cosine, except you eliminate the pi over 2. So this one is going to work out like this. For the range, you would say 0 to 90, but exclude the 90, because the secant's undefined at 90 degrees, and then 90 degrees to 180 degrees. Okay? So just like the last problem, you need to be either in quadrant 1 or you need to be in quadrant 2 because it's an inverse secant. Since this is a negative, that's going to force you to be in quadrant 2. So the meaning of this problem is the secant of some angle theta is equal to negative square root of 2. All right. Now, there's a couple of ways to do this. I think one of the best ways to do this is just go ahead and change this to a cosine. A cosine is the reciprocal of the secant, and then it would be wise to rationalize this denominator. So if you did this, you would have negative square root of 2 over 2. Now all you're doing is looking at where x is, negative root 2 over 2. So that happens here. Okay, that's where x is going to give you that value. So that means the answer in degrees is going to give you 135 degrees. Okay, moving to the next thing here, the other kind of problems that I want to look at are these composition of function type of things here. All right, so let me move this unit circle down here, and we'll go over how to do these. Now, these things right here, when you're doing a composition of functions, you don't have to go through and ever find the angle. You do these without a calculator. You don't need a calculator. So the first thing that you want to do is determine what quadrant that you're in. And determining the quadrant is all about what the inverse trig function is that you're doing. So you've got an inverse tangent of square root of 3 over 3. And the meaning of that is the tangent of some angle theta is equal to square root of 3 over 3. Now, since this is a positive number, you have to remember that the range of an inverse tangent is negative pi over 2 to pi over 2. Okay, so that means you're ranging, the answers are going to be ranging either from quadrant 4 with a negative angle through quadrant 1. Okay, like that. So we know we're in quadrant 1. The reason we know that is because this is a positive number. Okay, so the tangent is positive in quadrant 1. Okay, now what we need to do is just focus on finding x, y, and r. The definition of a tangent is y over x. So that's going to mean that the y value is square root of 3. The x value is 3. Okay, and since we're in quadrant 1, they're both positive. Then we can use the Pythagorean theorem to find what r is. So we're going to take x squared plus y squared equals r squared. So that's going to be 9 plus 3 equals r squared. That'll be 12 equals r squared. Then we take the square root of both sides. We're going to get r equals, and plus minus, and I'm going to break this up into 4 times 3. Now the thing is, r is always positive. That's another important basic thing to remember. So that means you're going to get r equals positive 2 times the square root of 3. Okay, so we got that. Now, why are we going through all this? Because ultimately in this problem, we're doing the cosine. So we're doing the cosine of some angle theta. See, theta is the answer to this inverse tangent. So if we do the cosine theta, then we are doing x over r. And keep in mind on this, we're not really in a unit circle on this because I've got x and y are 3 and root 3, and r is not 1. So what we have to do is just do x, which is 3, over r, which is 2 root 3. And that's an okay answer to the problem. I don't mind the answer being written that way, so that's okay. Or you could rationalize the denominator by doing this, and if you do this, you're going to get 3 times the square root of 3 over 2. Square root of 9 would be 3. So you'll end up getting, you can just cancel that out. So you get square root of 3 over 2. So you can take the answer either of those two ways. Okay, and I think on this problem you're getting exact answers. Okay, so you want to do that without a calculator. Okay, next one. What we'll do on here is look at, this one's got an inverse sign in it. So again, this part right here is going to tell you what the quadrant is. So the meaning of this is the sine of theta equals negative square root of 3 over 2. Because there's a range, that will tell you what quadrant you're in. So the range of an inverse sign is negative pi over 2 to pi over 2. Which means that the answers to this problem are ranging this way, either in quadrant 1 or in quadrant 4. Okay, like that. Now, since this is negative, that means you have to be in quadrant 4. Right? So the range is what tells you what quadrant you're in, and that's important in these problems. So now, what I'm going to do on this is, there's a couple ways you could do this. I mean, you could get this angle on this problem. You could go through and just see where is y equal a negative square root of 3 over 2. Well, you can figure out where that happens and get that angle if you want to. But I'm going to do this like this. I'm going to use the definition that the sine is y over r. And since we're in quadrant 4, y will be negative and x will be positive. So what we're getting is y is negative square root of 3 and r is 2. Now we got to find x. So we'll use the Pythagorean theorem. So we'll have x squared plus parentheses negative square root of 3 squared is equal to 2 squared. So that's x squared plus 3 equals 4. You can subtract 3 from both sides to get x squared equals 1. Square root both sides, and technically you're going to get x equals plus minus 1. That's the answer to that equation. But since we're in quadrant 4, I'm sorry, x has got to be positive. Okay? Then, ultimately in the problem, you're finding a secant. So the secant of theta, we never found theta, we never had to, but secant, by definition, is r over x. So we'll have 2 over 1, so the answer to that problem is 2. Okay, so there's an analysis to it. There's not a lot of work to do on your paper, but there's a thoughtful analysis that goes on with these problems. Okay? All right. Okay, let me scoot my unit circle down here. And I think that's it. I guess I'm done. Wow, cool. All right, so I'll post these problems on here for you to study, and hopefully this will help you. To me, this part of the test is the harder part of the test. You're doing graphing, and you're doing these inverse trig functions, okay? Study it hard. It's all doable, all right? Just follow the procedures I taught you and you will have a chance to do great. All right, good luck.